So in this video, let us solve question number 19th of exercise 5.1. Show that the function defined by g of x is equals to x minus greatest integer less than or equals to x is discontinuous at all integral points. So we have to show the function g of x is discontinuous at integral points. So before solving this problem, so let us see the meaning of greatest integer less than or equals to x. So if you consider some examples, so greatest integer less than or equals to 1 means what we are getting. So we have to consider the integers which are less than or equals to 1. So if you consider the integers less than or equals to 1, what we are getting? 1, 0, minus 1, so on. So among these integers, greatest one is 1. Similarly, if you consider any integer, it may be 2, what happens? Greatest integer less than or equals to 2 becomes, that is 2. If you take any integer, it may be positive or negative. So minus 10 means what we are getting? The integer, greatest integer less than or equals to minus 10 is minus 10. But if you take some real numbers, suppose if you take 0.5, so obviously 0.5 is not a integer. So what happens? The greatest integer less than 0.5 is 0. Similarly, if you take 0.9, what happens? Greatest integer that is less than 0.9 is 0. So if you take any number that is from 0 to 1, so here 0 is included and 1 is excluded, what happens? The value of greatest integer x becomes how much? X will be 0. Similarly, if you take number from 1 to 2, so 2 is excluded, 1 is included, the value of the greatest integer x will be how much? X will be 1. So same thing for positive real values. So similarly, if you consider negative real values, suppose if we consider the values from minus 1 to 0. So here 0 is excluded. The value of greatest integer x will be how much? X will be minus 1. Suppose if we consider the value of minus 0.5. So minus 0.5 is not a integer. So if we consider integer, greatest integer less than minus 0.5 will be minus 1. So if you take any value from minus 1 to 0, excluding 0, the value of the greatest integer is minus 1. Similarly, if you consider the values from minus 2 to 1, so what we'll get? The value of greatest integer will be minus 2. So on. So this is the definition of greatest integer less than or equals to x. So what happens? If it is a integer means, suppose x is the integer means, the value of greatest integer less than or equals to x will be x itself. Otherwise, we have to consider the greatest integer. Suppose it is a real number other than integer, means we have to consider the greatest integer less than the given quantity. So let us see the graph of this function, that is greatest integer less than or equals to x. So if you draw the graph of this function in the coordinate plane, so 0, 1, 2, 3, so on, minus 1, minus 2, minus 3, so on, minus 1, minus 2, minus 3, 1, 2, 3. So at the point 0, so greatest integer less than or equals to 0 means it will be 0. So from here we can conclude that what if you take any value from 0 to 1 excluding 1, what happens? The value of the greatest integer less than or equals to x will be 0. So excluding 1, so the value of the function will be 0. So similarly, again if you take any value from 1 to 2 excluding 2, the value of the greatest integer less than or equals to x will be 1. So if you take any value from 1 to 2, so 2 is excluded, the value of the function greatest integer less than or equals to x will be how much? That is 1. So similarly, if you consider any value from 2 to 3, so excluding 3, what happens? So the value becomes 2. So here 2 is included, 3 is excluded. Similarly, for negative values, so what happens if you take values from minus 1 to 0 excluding 0? So the value of greatest integer less than or equals to x will be minus 1. So here 0 is excluded till where? Till minus 1. Similarly, from minus 2 to minus 1, so minus 2 to minus 1, the value becomes how much? Minus 2. So here minus 1 is excluded. So what happens? Minus 1 is excluded till minus 2. So this is the graph of the greatest integer less than or equals to x functional graph. So now if you see the graph, what happens at the integral points? So at the integral points, what happens? The function is not continuous. So there is a break at the integral points. So we cannot draw the graph without lifting the pen at the integral points. So the function is discontinuous at the integral points. So this function is what? This function is not continuous at the integral points. So now let us solve this problem. So solution, the given function, the function is g of x is equals to x minus greatest integer less than or equals to x. So we have to show that this function is discontinuous at integral points. So suppose consider any integer, let x is equals to n, where n belongs to z. So n is any integer. So discontinuous means what we have to prove? If the limit, left hand limit is not equals to right hand limit, that is not equals to the value of the function at the point, then we can say that the function is not continuous. So let us compute the value of the function g of x at integral values. So that is g of n is equals to, what we will get? N minus greatest integer less than or equals to n. So that is equals to n minus the value of this is n itself. Suppose consider n is any integer. So what happens? Greatest integer less than or equals to 1 means 1. Greatest integer less than or equals to minus 10 is minus 10. So since n is integer, the value of greatest integer less than or equals to n is n itself. So n minus n is 0. So the value of the function g of x at the integral points is 0. So now let us consider the left hand limit. Left hand limit is equals to limit x tends to n minus g of x. So that is equals to limit h tends to 0 g of n minus h. We know that g of x is equals to x minus greatest integer less than or equals to x. So g of n minus h, that is equals to limit h tends to 0. G of n minus h means replace x by n minus h, that is n minus h minus greatest integer less than or equals to n minus h. So that is equals to limit h tends to 0 n minus h minus limit h tends to 0 greatest integer less than or equals to n minus h. So this value becomes, as h tends to 0, if you replace h by 0, so this value becomes n minus, as h tending to 0, the value of greatest integer less than or equals to n minus h becomes n minus 1. So see here. Limit h tends to 0, n minus h value becomes n minus 1. So consider one example. Suppose n is equals to 2 and h is a very small quantity which is nearer to 0. So take h is equals to 0.001. Then the value of n minus h becomes, so that is 2 minus 0.001. So that is equals to 1.999. So then greatest integer less than or equals to n minus h, that is equals to greatest integer less than or equals to 1.999. So that is 1. So this is general example. If you take any integer, so then we are subtracting small quantity, then the greatest integer less than or equals to n minus h becomes what? In general, we can write greatest integer less than or equals to n minus h will be n minus 1. So that only I have written here. So if you simplify, what we will get? N will get cancelled. So left hand limit is 1. So here the functional value g of x at integral value becomes 0. And we got the left hand limit as 1. So these two are not equal. So we can say that g of n is not equals to left hand limit. So from the definition of limits, definition of continuity, we can say that if these two are not equal means the given function g of x is not continuous at integral values, that is not continuous at x is equals to n, where n is a integer. So we consider only integer values. So what happens? At integral values, the given function is not continuous. So we have proved the given function is discontinuous at the integral points. So let us check whether the function is continuous other than integral points. So here the given function is g of x is equals to x minus greatest integer less than or equals to x. So now let us check other than integral points means that x is equals to c, where c is any real number and c is not a integer. So we are considering a real number and which is not a integer. Other than integers we are considering other real numbers. So obviously what we can write, this c lies between any two integers. So n is less than c less than n plus 1, where n is a integer. So if you take any real number, it lies between any two integers. Suppose if you consider 1.1, so what we can write, 1.1 can be written in between 1 and 2. That is n and n plus 1. So 1.1 lies between n and n plus 1. Similarly, minus 5.6. What we can write, minus 5.6 lies between minus 6 and minus 5. So that is n and n plus 1. So we are writing c which lies between the integers n and n plus 1. Now let us compute the value of the function at the point c. So what we are getting, g of c is equals to c minus greatest integer less than or equals to c. So that is equals to c minus greatest integer less than or equals to c will be what? That is n. See here example. So if you take c is equals to 1.1, what happens? Greatest integer less than or equals to 1.1 will be 1. Similarly, if you take minus 5.6 means greatest integer less than or equals to minus 5.6 will be minus 6. So we are taking this n. Again consider the left hand limit. Left hand limit is equals to limit x tends to c minus g of x, or that is equals to limit h tends to 0 g of c minus h. So that is equals to limit h tends to 0 g of c minus h. G of x is equals to this much. So g of c minus h becomes c minus h minus greatest integer less than or equals to c minus h. So here what we will get, that is c minus h, as h tends to 0, this value becomes c minus, so here c is a real number. If you subtract some smaller quantity, then applying greatest integer less than or equals to this value c minus h, what we are getting, if you subtract some smaller quantity, then what we are getting, we are getting 1 itself. Here also what we are getting, minus 6. In general, if you apply what we are getting n itself. So that is left hand limit, we are getting c minus n. Similarly, right hand limit. If you compute the right hand limit, so that is limit x tends to c plus g of x. or we can write limit x tends to, limit h tends to 0 g of c minus h. So both definition are same. That is equals to limit h tends to 0. So this should be c plus h. Right hand limit, it should be c plus h. So limit h tends to 0, g of c plus h. G of c plus h means c plus h minus greatest integer less than or equals to c plus h. Again, if you substitute the limit, so this becomes c minus the value of this one, greatest integer less than or equals to c plus h. Since h is a very small quantity nearer to 0, again by seeing these examples, what we can conclude, this value will also be n. So we can clearly see that left hand limit is equals to right hand limit. So that is equals to the value of the function at the point c. So all these are equal when what? When c is a real number and c is not a integer. So except integer, we have to consider all real numbers. Then what happens? The function is continuous. So if we see the graph of this function, so what we will get at the integral points, the value becomes 0. At the integral points, what happens? Suppose x is any integer, then g of x value becomes x minus greatest integer less than or equals to x will be x itself, that is g of x value becomes 0. So g of 0 becomes what? 0 minus 0. Again g of 1 becomes what? 1 minus 1 means 0. At 2, again g of 2 is 0, g of 3 is 0, g of 4 is 0, so on. Similarly, if you consider negative integer also, g of minus 1, so minus 1 minus greatest integer less than or equals to minus 1 is minus 1. So minus 1 plus 1 becomes 0. Similarly, g of minus 2 is also 0. So at the integral points, the value of g of x is 0. So other values, if you consider, suppose g of 0.5. So what we'll get? G of 0.5. So that is 0.5 minus greatest integer less than or equals to 0.5. That is 0.5 minus 0. So that is 0.5. So if you consider any value from 0 to 1, so excluding 0 and 1, what happens? Its value will be as it is. If you consider 0.1 means we are getting 0.1, 0.2 means 0.2. So we can draw a straight line till where? Till 1. So this is the graph of the function from 0 to 1. So excluding 1. Similarly, if you draw the graph from 1 to 2, what happens? Suppose consider 1.6. So g of 1.6 means that is 1.6 minus greatest integer less than or equals to 1.6. So 1.6 minus 1. So that is equals to 0.6. So 1.1 means we are getting 0.1. 1.2 means 0.2. So till where? Till 2, excluding 2. So what we are getting? 1.1 means 0.1, like this. Again we are getting a similar graph which is parallel to previous line, excluding 2. So same thing happens for the values in between 2 to 3. This is the graph along positive axis. So now suppose consider negative real numbers. So suppose consider g of minus 0.5. So what we'll get, g of minus 0.5 means minus 0.5 minus greatest integer less than or equals to minus 0.5. So that is minus 0.5 minus greatest integer less than or equals to minus 0.5 is minus 1. So if you simplify, we will get 0.5. So what we can say here also at the point minus 1 we are getting 0. Then at the point minus, suppose consider g of minus 0.9. g of minus 0.9 means we are getting minus 0.9 minus greatest integer less than or equals to minus 0.9. So that is minus 0.9. Here this is minus 1. So what we will get, 0.1. So minus 0.9 means we are getting 0.1. Again minus 0.1 means we will get 0.9. So again we will get a same graph similar to this one. So we can extend the graph for other values also. If we draw the graph, what we will get? We get graph like this. So by seeing this graph, what we can say, the function is continuous for all real numbers excluding at the integral values. So at the integral values, so there is a breakage. Thank you.